right, today we're looking at topic 8-5, learning about experimental and theoretical probability. Go ahead and update your table of contents at this time, and then we'll begin the lesson. First, we need to start with the definition. Experimental probability. Experimental probability is the probability that you find based on actually doing an event or experiment. So an example might be flipping a coin 100 times. And when we flip that coin, it lands on heads 63 times, it lands on tails 37 times. So what is the experimental probability? Well, the experimental probability of heads is the number of times it landed on heads over the number of tosses. Okay? Anytime I see a fraction over 100, I like to change that to a percent. So our probability is 63% that we're going to land on heads. Next, we need to define theoretical probability. So theoretical probability is the probability based on known facts or characteristics of what should happen. So what should have happened when we flipped the coin 100 times? Well, there's two possibilities, right? We have the coin. It's either going to land on heads or tails. Okay, so the probability of heads, if it's a fair coin, is 1 out of 2. It's half. So this is our theoretical probability. The theoretical probability of landing on heads would have been 1/2. Well, in the first example with the experimental was 63%, where the theoretical is 50%. So you see we've got a little bit of a variation there between the experimental and the theoretical. And that's common. But what happens is as you run an experiment more times, your experimental starts to get closer and closer to the theoretical. Imagine right now if you were to flip a coin 3 times and you just use that for your experimental. It might land on heads all 3 times. Who knows? And that would be 100% probability, and that's really far from 50%. But the more times you throw the coin, the better sample you get. This is something to keep in mind when we look at sample size later on with our data analysis chapter. So we went all through here. Outcomes can be predicted by setting up a proportion. So the probability as a fraction is equal to the ratio of the known and the unknown. Let's look and see what that actually means. So we have an example here where Khan is conducting an experiment to find the probability of getting 0, 1, 2, or 3 heads when tossing 3 coins on the floor. The results of his experiment are given to the right. So he's just taking his hand, he's taking the 3 coins, and they're landing on the floor. And that's his experiment. Is he getting, whether he's getting heads or tails with all 3 tosses. So the graph, the number of coins with heads is shown here. The number of tosses is shown here. Now we have a total of 22 tosses. And it says based on the results in the bar graph, what's the probability of getting 3 heads on the next toss? Well, with his total experiment, he threw 22 times, and he landed on heads 2. So 2 out of 22 is the experimental, and you can simplify that to 1 out of 11. So 1 out of every 11 tosses is going to have 3 heads. That's the probability of 3 heads in this experiment. Okay. Based on that experimental probability, how many times should he expect to get 3 heads in the next 5 tosses? in the next 55 tosses? Well, if he gets 1 every 11 toss, we set up a proportion to figure out how many he gets in 55 tosses. 11 times 5 is 55, so then x is 5. So the probability of getting 3 heads in 55 tosses is 5. You'll get 5, you'll have that happen 5 times. That's the experimental. What about the theoretical? What's the theoretical probability of getting 3 heads on a toss? Well, we have 3 options, 3 possibilities. So this is toss 1, toss 2, and toss 3. And each time, there's a 50% or 1/2 probability. Right? It's either heads or tails. And we multiply those together. So now 2 times 2 is 4, times 2 is 8. So the probability of getting 3 heads on a toss is 1/8. That's the theoretical. Now remember, the theoretical was 1/8, and the experimental was 1/11. And we're talking 22 tosses, so could it get more accurate? Probably, if we went a little further, but those are pretty consistent. They're pretty close. Go ahead and try on your own these exercises. They're in your study guide workbook, page 67, or you can work them right here. You can come back and ask me for the key after you've tried it.